Hello, welcome to Ekidel, where I will train future civil and structural engineer. My name is Justice Mwaka and I am your instructor. Today, I will be showing you a residential building design using the software Protastructure. And the version of the software I'm using is 2025 of the Protastructure software. And in terms of AutoCAD, I'm using 2026 version of AutoCAD. So looking at this right now, this building is a residential building which has quite some features and all that. Now on this building, it has a green area at the top, which you can see here, green area at the rooftop. And then also on the first floor, which is a G+1 building, it also have some parts which is like a bungalow, and some part also which is the master bedroom closet and all that. Now let me now walk you through to the roof plan. This is the roof plan also. You can see the roof plan here and all that. Then if we now go to the elevations, which is the 2D elevations, you can see how the building looks like on the side view. So this is the building we are about to design the structural perform the structural design. Also, you can see the other views for that. Now, if we now go to the 3D model view, which we have here, this is the site plan. If we now go to the 3D model view, which we have here, you can see what we have on the 3D model view here. Correct. So this is the building we are about to perform the structural design, and this is a real life building plan which we're designing for Mr. J. Okay, that's fine. So this is the building we are about to perform the structural design. This is the side view, and then this is the top view. So you can see the green area around this place here, which is also carrying a concrete slab decking, okay, or concrete slab. So with this now, we have to now perform the structural design for this using the software Prota 225 version. Now, once you get your building plan like this, as a structural engineer, the first thing to do is to study the building plan and look at the features that is contained on the building plan, because that will help you on how to plan the structural framing, knowing that it is the framing of the structure that actually carries the structure. It is at that time you have to consider the size of the columns you are going to use and the column position and how you want to panel the structure and how you want your beams to place. So all these things comes in the stage of the structural framing. Okay, that's fine. So with this now, we have done so many videos about structural framing, and I've told you guys about the rules on how to plan your structures or your columns and all that. So with this now, I'm going to move to the structural framing, which I've already planned for this structure or for this building you are seeing here. Now, looking at on my screen this side here, you can now see the structural columns which I've already placed. Now, if you look at the columns clearly, you can see that I have two colors for the columns. Some are green and some are magenta colors. Okay, that's fine. Now, the green columns are the one that is going from the foundation down to the first floor, which is the G+1, which is to the roof. Now, these other ones that are magenta are the ones that are going to stop at the slab. Knowing that on our 3D elevation here, you can see that some parts of the buildings are bungalow, all right, which is having a roof, and also a bungalow that's having a slab, because the top of that place is the green roof area. Okay, that's fine. So it is best to spend time to study your plan before you can now begin your structural framing. But in this case, I've already done the structural framing for this. Okay, that's fine. So with this now, once you're done with your structural framing and knowing how the columns are going to be placed, now if you look at two also, you can see that we have different column sizes. This is the smaller column of 6 inches. All right, while this is column of 9 inches. Okay, that's fine. So the client will specifically wants this building the same way it is, which is nice. So with that, I have to use columns to follow most of the edges and all that. So you can see that we'll have different column sizes, all right, just to make sure we follow the actual shape of the building and make sure everything is designed against cracking or another. because most times if you have some kind of curves in your building and you don't place a column at some edges, it might cause some cracks around that edges. So you can see how we have to make the column to flush all through. So with this now, once you're done with your structural framing like this, it is now time for you to now export this building plan to the software Protastructure or to any of your structural design software, for example, Start Pro, ETABS, and all that. But I love Prota very, very well. So with this now, you can see that we'll have several drawings here and all that. I've also done my superimpose. You can see that on the first floor now, which is on the G+1, on the first floor here now, you can see that only the green columns are the one that is extended from the ground floor down to this place. On the first floor, we don't have all other columns because this one has already stopped at the ground floor, and this one also has only the slab, so the column does not extend. These things you're seeing here are not columns, they are block walls, like fancy block walls around the green area, which you can see directly here on the 3D view here. You can see these are the block walls. Okay, that's fine. So with this now, we will then move into the structural design of this building. So with that now, now once you're done with your framing, you have to save this plan separately. I know that I have taught you guys how to save your structural plan very, very well separately, so which I have also done here. And you can see that we have only the plan here, and I have put this plan on coordinates. Okay, that's fine. So with this now, we're now going to export this plan alone to the software Protastructure. Now before we go, don't forget this month of April is our anniversary month, and on every anniversary month we offer 50% discount on all our services. So with this now, if you want to enroll for Ekidel mentorship training on the design of structures and all that, you can enroll that for this month beginning from 1st of April to the 22nd of April and all that. After this period, it's going to get back to its normal price for our mentorship. So make sure you gain this 50% discount during this period on all our services. And you can get our store link on our bio here by saying Ekidel online store on seller. That's fine. So right now, or just say seller.com/Ekidel design. So with this now, we will then move into the software Protastructure by exporting this building plan into the software Protastructure. So with that now, I will then come down and then minimize. This is now the Protastructure interface and all that. Now this is the design I am working on and all that, but I'm going to create a new drawing right now, which I'll come here and then click on what new projects. So on this new project now, you have to put in here the project name, which for me this is Mr. J's residential building. So I'll quickly come here and type that word now, Mr. J residential building. To put a space, make sure you put this underscore. Okay, that's fine. So once you put your project code, which means the project name, then come down here and make sure you choose your code, design code. You can see that we'll have several codes here and that. Now the client is a Nigerian, so with that, in Nigeria we use this Euro code or BS code and UK Euro code. So with that now, you can see that we have UK BS code and UK Euro code. I want to use Euro code because Euro code is a code that what supersedes BS code. So this is a new code that we use now. So I'm going to use UK Euro code. So with this now, I'll choose my code here and then come now and then say what? Okay. So with this, by saying okay now, it's going to bring up a new project or design interface, which we are now going to import our building plan from AutoCAD to this to now begin to perform our design. Now this is now a clean or a fresh project interface for in this software Prota 225. Know that many things has changed here in terms of loading and all that, which you also see on this video. That's fine. So with this now, the next thing to do right now is now import your structural framing model that you performed in AutoCAD or AutoCAD framing plan. So with this now, then come to this place that says what? Building setout. To import your building from AutoCAD down to this software Protastructure, just come here, begin start, and then come to this place here as a external reference drawing. You click on this place, that's fine. It will appear, these labels will appear here. Then come here and says what, add DSF. You can see here, add DSF. Click on this place here. Then wait for it again. You now go to the place where you have it on your computer or desktop or laptop. Make that in this case, I have my own structural framing saved on desktop, and then under this folder here. You cannot see it here as a DSL file. Okay, that's fine. I'll then come now and then do what, say open. So with this now, it will be added here. You can just wait for a second now, it will be added here. Now on adding here now, you can see that nothing is showing yet on my screen. But if I come now and check this place here and say active, you will see a trace now will show on my screen automatically, having it as what, 00 coordinates, as you can see it here. Now this is a trace now. Now once you have done this, the next thing now is to import our model, which is the column and the grid line. Then if you want to use the same color you use in your AutoCAD, you can come here and say use color. You can see it here, all the color will change here. You can see it here, which is nice actually, for you to be able to model the building perfectly. So I'll just say use model, that's fine. You can see it here, 00 offset coordinates, that's fine. And this is the best, it must be on 00 coordinates. Now if you now come now, once you've done this, now the next thing to do is to do what, import DSF, because we set our column members with column grid line and axis with what, and then axis with what, a grid line. We now want to import those members for it to appear on this place as a structural member. So then come now to what, say import DSF. On this now, you can see the new interface now of what, 2025 importing DSF dialog box. So on this place, you can see that I'll have to uncheck wall, because I want to only import grid line and columns. This is why you must set your layers when you're creating your columns, doing your framing in AutoCAD as column layer, and then for the axis as grid layer. That's fine. So you must spell this name correctly, that's fine. So with this now, I'll leave everything here as default, then come now and click here that says what, import. On doing this now, it will convert the floor plan now to a structural floor design model, converting the columns to be what, to be a column member, and then the grid to be what, axis. Okay, that's fine. So with this now, once it's this thing that says print log, it is done importing. I'll then come now and do what, say close here, that's fine. Then I will now come now and say okay. If you say cancel, all these things will go off. So I'll just say okay here. So with this now, you can now see that we now have our columns, all right, and everything. If I come now and say 3D view here, you will see that what we have is only the column member and the axis. That's all, because we have not yet started inserting our beams. Okay, that's fine. So you can see how to import your structural framing from AutoCAD down to Protastructure. You can see a new innovation too on this new version of what, Protastructure. Before this time, you are not able to see your trace that came from AutoCAD on the 3D view interface. But on this new version of this software, you are able to see your trace. As you can see, your tracing plan, which makes design very, very simple. So you can see very, very realistic. So you can see how your drawings now, how your columns is also flushing with the line. So you can see how it is. This is very, very nice, and this is a new innovation, making design of structures very, very simple. Wow, I love this. That's nice. So you can see how everything now looks perfectly. So once you've done this now, the next thing now is to do what? Convert your grid line naming. You can see how this software names grid line, which is not really nice, because if you check on our CAD file here, you can see that these grid lines are named by what? By alphabet 1. You can see there A, B, C, D, and all that, and also 1, 2, 3. So we are going to change the grid line which you have on our here by 1, 2, 3, and other, and so on. So with that now, we are going to change them to match what we have on our architectural CAD file. Okay, that's fine. So with this now, to change your grid line, just come here, right click here on the grid line and say properties. And on that right now, then come here and type what the value that you need. In this case, I need 1. I'll say then update. That's fine. You can see it will change now to 1, and this is what grid line A. So I'll come now again and change this now to grid line A. That's fine, which is on this place here. This is only what A, and I'll press what update. That's fine. So with this we have now established what grid line 1 and grid line A. So with this same procedure, I'll use it to change for all of them. If I come to my 3D view now, I'll still see the same thing. As you can see here, we have just established what grid line grid line A1, which is A here, and grid line 1. Wow, I really love this trace work which you have here. That's so nice. This is so perfect. I really like this. That's nice. So this is how to import your drawing from AutoCAD down to the software Protastructure 2025. That's fine. So you can see how everything looks like. I can choose to come here, display here, and then remove or hide that grid line and all that for me to see the column and everything. But you can see, yeah, that's fine. So you can see how the column is now imposed on the plan directly. So this is the new version of this software. I can see how design is simplified, very simple, and everyone can be carried along. A student now will be able to understand this software very because it makes design more easier. That's fine. So in this stage now, we have just imported the building plan into this software. That's fine. So the next phase now that we have to do is to now begin to insert the beams, but before then we have to change the grid line naming that we have, which we just changed grid line A and 1. Okay, we will have to change for all other ones too to make sure they match directly the way we have on our CAD file. But if at all we want to name a new grid line, which is the structural grid line, then we can now begin to assign a new grid line which will be useful for the structural drawing during the construction. That's fine. So with this now, let's now move on to the beam insertion method. That's fine. Now, before we can insert the beams, as you can see, I have taken my time to make sure I renamed all the grid lines. As you can see, our grid line now that we have now matches the one that we have on our architectural drawing. So this is a very good thing for you to do, that your grid line matches with the one that came with the architectural drawing, so that during the construction you will not have some kind of issues in conflicting grid lines. Okay, that's fine. So make sure you spend some time to do all that. It might take you some time, but let me say that it's good for you to build that kind of culture, to make sure that your grid line of your structural drawing matches with the grid line on the main architectural drawing. Right? Although you are also to create some kind of new structural grid lines. For example, you can see that there are some grid lines here like 8 prime, 7 prime that was not on the architectural drawing. That's because structural drawing governs during the construction, but we still try to make sure we follow the grid lines too, and some things we have on the architectural drawing, maintaining the beauty of the structure. That's fine. So with this now, once you're done with this, then if you also check out on our 3D view too, you will also see that we have also, and that the grid lines too are all matching and all that. So with this now, let's now move on to the beam insertion and all that. So to insert your beams now, come to modeling tab here and then click on beams here. You have two drop down options. Go here that says what normal beams and not coupling beams. So come here and say normal beam, click on normal beam to display the dialog box here. Now on this dialog box now, next thing to do is to do what specify the width of your beam. This B here simply means what width of the beam. So in this case, the block the column thickness here is what 230. Therefore my minimum beam width or my assumed beam width will be 230 millimeter. Okay, for it to flush with the columns. Note, these are assumed. After our design, we will see or check if this column size this column size and this beam size which you're about to like add now is going to carry the weight of the structure and all that, and the weight and the loads which are going to impose on this structure here. So with that now, then for the beam, this beam depth now simply means what? The overall depth of the beam, including for the slab thickness. Okay, that's fine. Now, in this case now, this building has two slab types. Okay, note that this area, which is grid line 1 to 2, are bungalow or is a bungalow, and grid line 2 to 5 it has a G plus 1, and then grid line 5 to grid line 9 is also is a bungalow, but having a slab which is to be used for a roof green area. That's fine. So with that now, this 5 plus grid line 2 to 5, since it's a G plus 1, we are going to use a slab of what? 150. That means that the beam that will run here on this particular place, this from grid line 2 to 5 is going to have a beam depth of what? 450, knowing that this 300 here is for the clear beam depth and 150 here is for the slab depth. So if you add them all together, that gives you what? 450 depth of overall beam. So with that now, we are going to insert 450 beam around this place from grid line 2 to 5, where we'll have the G plus 1 from our CAD file. If you see the 3D view again, that's fine. So with this now, you can then see that we have now inserted the first beam. We'll then go again, we also have it all the way down to this other place here. That's fine. And again, continue again from this point here. Now we will have to be careful so that we will not make mistake. So follow again now from here all the way down here. That's fine. And again, we then go let's see, we then go from here now all the way down to this place here. That's fine. So with this, we then have that, and again we then go again. So just follow the same step to do that. Now if you like this video, please give this video a thumbs up and that, and also I would like everyone to upgrade to this latest version of 2025, because there are many things that are being modified and also added on this new version. Okay, that's nice. So I'll then continue again and then click this here. That's fine. And again, then continue again. Let me just press my escape key and finish up what I have here. Then continue how I have here to this place. That's fine. And again, continue again all the way down from now we now have from here to here. So please, if you like this video, please give this video a thumbs up, and also please recommend your friends and colleagues to Ekidel, knowing that our mission here is to teach the younger engineers and also to make sure everyone understands structural design as easy as it is. That's fine. So with this, then we then go again and then continue again, and also hope you are planning for our Ekidel 3 years anniversary here on our online space. That's fine. So we then come again now and then keep this here. Now, sorry, we will not have to put this beam depth here because this place is a bungalow. So with that, now I'll just remove this other side, right click here and then say delete. We are going to specify a different beam depth here because this is just a bungalow carrying just the roof. So so that's fine. So we'll then continue again to make sure we get all what we have first on the one that is carrying G plus 1, which is this area. So from here now all the way, there is no, we are not, then from from here then cross to this place. That's fine. And again from here now cross again to this other place here. So from here all the way down here. That's fine. Okay, that's fine. And again we then go again from here. We have from here all the way down to this other side here. That's fine. So you cannot see what we just done just now. Okay, there we then go again, escape from here all the way down here. That's fine. And again escape, then move again from let me see, nothing here, nothing this lobby. So again from here all the way down here. That's fine. Then we then have this slab here. I really don't want to have this here. So I'll just remove that beam there and then place a beam around from here all the way down to this other place here. That's fine. So I want to have my beam here. So I don't want to have any slab around this place. Okay, that's fine. This panel alone is okay for a slab which is less than 30 meter square area as standard. Okay, so with this now, for a solid slab, sorry, that's fine. So on this now, this is where our slab is going to be. This place here becomes a bungalow. So with this now, I will then come now, click on this, take this out, put a new beam, come to modeling tab, come to beam here, then put a new beam now for this bungalow area, okay, which doesn't have a slab. So with that now, since there is no slab, I'm going to remove the slab to the slab depth. So I'll be left with 300 alone. That's fine. And I'll then come now and insert this beam from here now to this other place here. So you can see that all I have now is a beam of 300, which you can see here. Now, knowing that this is just a lintel beam and it's a bungalow, I can go as far as reducing this beam depth to 250. Okay, that's fine. Then say updates. So I have 250 beam now, which I'm going to use on this 250 beam depth. And again, I will then come continue again. Continue from here all the way down to this other side here. Keep this here. That's fine. And again, continue again from yeah. Now the reason of using that so that I can be able to reduce the self weight because it's not carrying anything except the roof. Okay, on this particular side. That's fine. Again, I will then come again now. Now we don't have a different beam width because this beam width now, this other side, this other side here are 150. So I'll come now and reduce this to 150 beam width because of the block wall here, and also it is not also carrying any load. So this is like a lintel beam. All right. So this is like a lintel beam around this place, correct? That's fine. And also serving as a roof beam around this place too. So with that now, I'll then come here, just brace here up a bit. Okay, and again, brace this other side too, brace here up. That's fine. This now becomes a lintel beam, and also this also becomes a lintel beam. Okay, no entrance here. Yeah, there's entrance here. Also a lintel beam here. Then escape. Then come here, click on this, and then separate this here. Okay, that's fine. Let me see. Any need for this beam? No need for this beam because this is just so I will take off this off, yeah, just to save that cost. So there's no beam here. This will just be a block wall because it's already a bungalow on this this side. Yeah, so with this also I can quickly also save this beam without having this thing. So I can quickly save this, but I don't want to have a beam crossing here. Basically we can use a POP to cover it up and all that, so so that I'll be able to take off this beam here. Okay, so with that now I'll just make sure I stretch my grid line, stretch it a bit from here all the way down here. That's fine. And again, stretch here again from here, click here, click here, stretch, yeah, stretch from here all the way down here. That's fine. So with that now I want to remove this beam because this is actually a bungalow area of this building. So I'll then come here, right click here and put a beam here. All right, that's fine. So you can see that most times some things we do on the framing might change a bit. Yeah, because while you're doing your modeling, you are also trying to reason. All right, think. So with that again now I'll do the same thing again. Come here, escape, then put another one here again. Yeah, that's fine. So with that now we have just removed or save cost on putting this beam here. That's fine. So these two beams now we also serve as the roof beam that can hold the pole lines, or sorry, that can hold hold the rafters and all that on this particular bungalow section area here. That's fine. So with that now we have done the modeling around this area. Let's now move on to this other side now. Now on this other side now, this place now has a green roof area, but it also have a slab. So with that now, this is meant to have a beam. Okay, that's fine. So with that, we are going to introduce another beam again on this other side. Now, will this beam depth on this particular area of this green area be what will now be the depth, knowing that the width is the same 230 because of the 230 block work. So what would the depth now? This depth now, this place basically is like a sit out or green roof area. So we can use we can still use beam depth of 350, but just to save cost, we can go, sorry, it's for 450, but to save cost, we can go 350. All right. Okay, now on this place now, we are planning to use a slab of 120 on this area and not slab of 150 for this particular area here, because no much function is happening here, just a sit out area, but this is where the living room is and all that. So we are going to use a slab of 120 on this area and a slab of 150 on this area. Okay, that's fine. So with that now, if we have 300 plus 120 slab depth, that's giving us what, 320, sorry, the that's 420, right? So but yeah, 420 basically, that's what is meant to be our, okay, what if we use a slab depth of 100 on this particular area? So 100 plus 300, that's 400. So the same thing, so we cannot use 350 here, all right, because you have to calculate your depth of that. Although this thing can still work structurally, but just that since the concrete section now becomes small, the whole load now is going to go to the steel, and in that case it will make the reinforcement to be what, bigger, or having so many numbers. Okay, so with that now, let's still maintain a beam depth of what, 450. Okay, that's fine. So our but our slab here around this beam area will not be 150, it will be 120. Okay, that's fine. So actually we would have gotten a depth of beam of 420, but we will just use 450 just to have a seamless beam flow from here to here. That's fine. Knowing that there is still a change of level, you can see the level here, that sorry, this is the ground floor, but but on the first floor the level here is different from the level here. Okay, that's fine, which if you have the CAD file you can just take that out right now. So with this now, we'll then move on now from here now all the way down to this place here. So come here, put this now on this place, that's fine. Then press an escape key, come again now from here all the way down here. Now there will be the same thing. This is a column of 150 by 460. That's fine. So come again here right now from here all the way down to this place here, and again from escape, from here escape again, take again property again, then from here, from this point all the way down to now before I put this other one, I'm meant to provide a primary beam first. So put this from here to here, that's fine. Then before we can now provide for this other one here, properties again, that went off from here to here, that's fine. So with this now, let's now look at for this whole store. Let's not see escape. Yeah, now we have a beam flowing from here all the way down here, that's fine. Let's see. Now I want this to be a cantilever beam, so with that now I'll just escape that, just delete that, escape. Now make sure I move this. I want to move this, right click here. Now this we have this on our CAD file. If you have that, now let me show you what I want to achieve here now. This particular one I want to achieve now is to achieve this this particular wall you are seeing here. Let me show you that on our CAD file here. Here, that's fine. So I want to achieve this wall which I have. Let me see. Correct, you can see this wall here. So there is also a wall around at the top here. So there is a little bit cantilever beam that's going to carry that wall. So with that now, we want to achieve that just now. So I'll come now and then click on this beam, right click here, and then properties of that beam, and then continue again from here all the way to flush it direct at this face. That's fine. So we now have a cantilever beam there. That's fine. Again, I'll then come again, continue again, escape, then flow from here all the way down here. That's fine. This column you're seeing here is a stand-alone column. All right, it is only at the rooftop that it is being it is only at the rooftop that it has a connection. Let me see that again. I'll show you right now. So escape that, then let's see, then come here from here all the way down here. That's fine. escape again. Okay, just come here, then down here, that's fine. Again, let's see. Again, from here all the way down here, that's fine. Again, escape. Let's see. Let's see. We didn't have okay, this is 150 wall, so we don't have another one here from here all the way down here. That's fine. This is 150 block wall, so I would like to use a 150 beam around here. Okay, so escape first. Let's see. Now there is based on the size of this dining and this place here, so we want to make it like a flush, right? To have a flush all the way down, so we have to do this now. So because of the size of this panel, we have to introduce a beam, all right, a secondary beam that will divide this panel into two to reduce the size of the panel, because this is already too big. So with that, now we have to just click on this. Now this beam here will not carry any wall load, okay, because it's just there to divide the span of the column, all right, or sorry, of this panel. All right, that's fine. So with that, now that remains T450. Okay, that's fine. Now on that note, now I can choose to reduce this beam. Okay, let me see. I can choose to leave the beam depth as it is. That is fine. Escape now, then come now, then make sure I come now and then reduce this to 150 wall thickness, then come here and then make sure I put my beam here. Now on this, now I will need to flush. Okay, that's fine. The beam has already flushed to the column. That's fine. Again, the same thing here. Click on this now, then go all the way down here and then click it. That's fine. Now on having this now, since I have my both primary beams now, I will now come and insert this other secondary beam that are going to join here together like this. So I'll escape now, come here, back to what 230 block beam width, then come here again and then come now and put this one here. That's fine. So with this now, we then go again and then let's now establish this other beam that is running here, the same 230 beam running here all the way down here. That's fine. So with this now, you can see that we have a portrait. We have a portrait section here. So with that, I'll just escape now. Now I'll have to come now and then come here, say 150, and then come now and then put a beam here. That's fine. Now that's fine. So with this now, then what, escape now. So on escaping now, let's see what is left. We want to have a beam here, else the slab they're going to have an issue. So we're going to come here right now and then put a beam here. That's fine. Of 150, that's okay. Let's see from here now all the way down here. That's fine. Let's see. All right, that's fine. So with this again now, escape again, escape. Now on escaping that, let's see what we left. Now we have this left here. Now on this place now, we need to do what? We need to offset a grid line on this particular area. So I will just escape now, right click now and say what, measure. I want to take the distance of that. So just escape again, right click and then measure. So come now and measure from the midpoint here all the way down to the center of this grid line. That's fine. So I have a distance of what? You can see D here, the X, right? This is going for vertical, so it's what, 230. Basically it's 230. So I'll just escape now. Even if it didn't offset, just click on this grid line, right click here and then say offset, and then come now and then click here to just put on the midpoint there. So escape now. Now this grid line now tends to be too big because it is only useful from this point here to this point here. So having it straight like this is not useful. So I'll come now, stretch it backwards, stretch from here all the way down to here that is being useful, and then stop there and again come again here, click on this one, right click now and then say what, stretch. That's fine. Stretch from here now, from this point here all the way down to this other side. Now on this place now, sorry, it's not it is not still useful here. It will stop directly here. So I'll come again, right click now, stretch from this point all the way down to this place. Now if you want to enroll for Ekidel mentorship, this is the best time for you to enroll now that we have our anniversary. Okay, that's fine. So you can gain 50% discount. Okay, that's fine. So with this now, then come now, right click now and then come here and then do what, properties, and convert this now to ghost axis by removing these two bulbs and then say update. We now have to be what a hidden axis, because it's a minor axis that's going to be used for just this block wall here or for this beam here. That's fine. So I'll come now do what, come here now and do what, say close. So with this now, with this, you can see what we have just got. Now I want to convert this wall now, this particular column that we have, to a very long column that we also have. Let me just show you right now. Now I want to convert that column now to something like this, because I want to have this shape flowing. All right, so I can convert that column now to something like let me just do something for you right now, something like this. Correct. So what's the width now? Let me see. That should be 150 width. From here all the way down here is 150. So I'll then move it from here. I'll just stretch it now from here all the way down to this place here. From here all the way down here. Let me see. That's fine. So I have something like this. So what's my length now? I can still modify this now on the software. So I just confirm the length now. What is the length from here to here? That's fine. This is 460. Now then come again now. What is the length from here now to here? I have what? I have 346. That's fine. 346. And what's the length from here to here? I have 114. 114. That's fine. So I'll come now, minimize this right now. Then come here on this software. Click on this, right, come here and then properties, then come and adjust this. B now becomes what? 460. Sorry, 460. The 460. Then update. Let's see first what's gonna happen here. That's fine. I'll now come now and then say this here is 114 minus 114 minus, I think so, minus sign, no, minus sign from here, and then say minus sign, come here and put minus, and then come here and make it what, 150, and then zoom. That's fine. I'll update, and then you can see what you have right now. That's fine. So with that now, since we have made some changes here, you'll be seeing that this bin now, you will be having some kind of shape. Okay, so it's just to do what, to remove this bin, or just say properties of it and then say update. Okay, for it to adjust itself to that shape. Okay, that's because now it now that change to what, to how it does not flush. That's fine. Then come here and close. So with that now, on closing now, I'll then come click on that beam, properties of that beam, and then come now and then click on this point and put my beam here. That's fine. So with this now, then I see how we just got this beam perfectly. Yeah, that's fine. So again, let's now see what we just got. So we undoing that now, you can now see we now have to do what, let's see. That's fine. So we have done almost everything needed right now on this building plan. Let's now look at the 3D view of the half. So on this now, you can now see what we just got just now. You can see how our beam now is perfectly. That's fine. So you can now see how we have also modeled what we want to model. You can see the shapes, how the building is. If you have the CAD file, you can just flow that up. That's fine. So with this now, it's now time for us to go and put our slab. You can also see that on this new version, any clone that is cantilever, you can see the cantilever sign showing. Okay, that's fine. So you can see that it makes this new version of the software, the 235 Protastructure, makes it more easier for you to understand structural drawing, showing you that this is a cantilever. You can see that this angle you're seeing here, this triangle, shows the cantilever. That's fine. So with this now, let's now go on. Now we're not gonna put our slab. To insert your slab, after inserting your beam, to put your slab, now you can, this is where everything gets changed on the previous version. This new version now has a very new way of loading of applying load. So if I come to my modeling now and then come now and then click on my slab here, you ask me to define the load case first. That's fine, which is normal as before. I'll say yes, define. Now you can see that the interface now is quite new from what you know before. Just hold on for a while for it to display. Now if I come now and say what, loading generator here, all right, just hold on for a while. You can see now, if I then come now, just say okay here, all right. You can see this is quite different from what you did before. So you can see that if you're doing for a steel structure, you have to specify the steel structural load differently. All right. So before you can use one load for both concrete and steel, but in this case, you have to define the steel separately. So you can see how different it is. So you have for ultimate load for concrete, ultimate load for steel, service load for concrete, service load. So you can see how it is, right? Correct. So but this is just a concrete building, okay? It is not a steel building. So because I don't have steel on this structure, and even I have both steel and concrete, I would have come and specify for the steel also here, which on doing that, I'll show you that on the next video, how to specify for steel load, okay? That's fine. So in this case now, since I've already clicked on this place here and then say okay, because we don't have wind load here, so I'll not put anything like wind load, and then come now and then click on what okay here, then I'll come now and then do what say okay here. So on the okay now, it now display the slab or the slab property will not display here. Now knowing that I have two type of slabs here, one here is 150 and one here is 120. So in this case now, I will then come here and then click on this place and type what 150, which is my slab my slab thickness, right? That's fine. So on this other place now, I'll then come and click here that says load. On this load now, I'll define my dead load. Dead load now, I'll say 1.5. All right, then my life load now, it says is for residential building. Now come here and click here and choose what residential, general domestic use, because I'm doing what for residential building. Now the reason how I got this 1.5 is because one, dead load comprises of finishing load and what partition load. Okay, that's fine. So right now finishing load can range from what 1.0 to 1.2, and partition load can range from 0.5 to 1.0. Now I choose my finishing load to be what 1.0 and my partition to be what 0.5. If you add them all together, you get what 1.5. So this is how I got my 1.5 dead load. It is unfactored load and not factored load. Okay, that's fine. So with this now, once I've picked on these two, you can see my slab safe weight here automatically is there. Once you pick your slab thickness, you see that the slab safe weight here will just be here. Now this is my concrete cover for my slab. Okay, that's fine. So with this now, I'll then you can see the other method here, but I'll just give it as what beam. Okay, that's fine. So with this, I'll then come now and then begin to insert where I have my my slab of what 150 depth. That's fine. So I'll put that here, then come again here, click on this, and then just click on the place where I have my slabs, okay, of 150. So I'll come now, click here again, come now and then click on this particular area here where I have my slab here. So I'll make sure I click here. That's fine. And again, come here and then you can see what's happening here. Because of the shape that we have here, we are having this kind of, you can see that it's now accepting to insert slab as a whole, like a rectangle where the beams are. So with this now, we are going to change the change the option and then use what say pick point. Okay, pick point method. So I'll come now and then begin to pick my point. I'll pick here as my first point. Okay, that's fine. Then again, move now, come here, pick here my second point. That's fine. Okay, that's fine. Then come now, come here and pick my third point. Most times this might not work, but I'll still show you. If that didn't work, I'll show you what we'll do next. Okay, that's fine. So I'll come again now, pick this. That's fine. And again, come here, pick this. That's fine. And again, come again now, come here, pick this. That's fine. And again here, come here, pick this point here. That's so just to pick where the slab is. Okay, that's fine. So if maybe you are new on Ekidel, please consider subscribing. And if you have not subscribed before, please, if you're an old subscriber, you can join our Ekidel mentorship, which is the one-on-one training on structural design, or you join Ekidel membership here on YouTube. Okay, that's fine. Just if you can see the join button, click on the join button and then choose your level and all that. Okay, that's fine. So you can see that most times this does not work. Okay, you can see that it is not working here. So this is, you can see the far as we can go. So what we can do right now is now change the whole concept now. So I'll come now and then click back, just click escape key. All right, escape key, and then come back to my slab here, take this slab property here, right click here, and then what say property here. That's fine. Okay, that's fine. So on flowing here now, using the same pick point tool, you can just achieve this slab as you can see it here. So we then move on, you can see the slab here, then we don't move on again right now. So on this other place now, what we have here on this side are slab of what? 120, okay, 120 millimeter, okay, that's fine. So I'll come now and make my slab what? 120 millimeter, okay, that's fine. So I'll then begin to put in my slab, come here now and change to what? Beam region, that's fine. And then begin to input my beam again, my beams where my slabs on this other side. I'll click here for it to insert on this other side. This is a staircase, so leave here as void. So again, come again right now, click here and then click here again, here and then here. Make sure you click them very well. When you click the first time, maybe it not appear. Make sure you check it very well and then click again. Click. That's fine. And again, let's see again. Come here again. You can see the same thing happens here. Then let's see the other side. The same thing happens here and then here. So whenever you have this kind of slab opening this way, there where you have column stretched or supporting two members, two beams, okay, you'll be having issues inserting your slab until you have to use a pick point method to do that perfectly. Okay, that's fine. So you make sure you have to change to pick point whenever I see such issues. So I'll come now and change to what? Change to pick point, right? Pick point, and I'll come now on this side now. I'll just come now and pick point like this one, all right? One from that point. Move this way right now. Click here, all right? Pick that point. Then move this to that side now. Or let me see. Yes, then move this to that side now. Pick this point here. That's fine. So the same thing, just apply the pick point and then pick all the points where you have your slab to be, and then you have where you all the points as the slab is covering, and then you have your slab. Okay, that's fine. So you can now see our slab here now using the pick point method. Okay, that's fine. So you can now see our slab now on the pick point method. So just pick the right point and then you will see your slabs there. Okay, that's fine. So we then come to this other side too and also apply the same pick points too by coming here. Let me start from here, pick from here, and again continue again, pick from here, pick from here. So whenever you have that this column spanning or supporting two beams with one column, you'll be having issues using beam region to insert your slab. Okay, so just use the pick point method, which is the best way to insert slab if at all you're having issues on slab insertion. Okay, that's fine. That the pick point method gives you your own right on how to insert your slab the shape that you want. Okay, that's fine. So I'll come again now and then come here, click here, and then come again now and then click here, and sorry, make sure you must see those points. Okay, you can see that here is 0.6, here will be 0.7, and here is 0.8. So make sure you see the point before you can accept it. Correct. So you can now see our slab now is now appearing here. That's fine. So again, I will then come again now. We also have a slab here too. Okay, so the same thing again, using people again and put your slab here. Okay, that's fine. Okay, so now on this now, you can see that we have now inserted all our slabs. If we now go to our 3D view now, you can now see what we have on the 3D view. Okay, that's fine. So this other place now is the bungalow area where the roof stops directly. If you look at our CAD file here on this screen you're seeing already, you can see the screen here. You can see, so you can see that on this other side now, you can see that this is a bungalow, and then this is where we have the first floor, and this is the other green roof area. Okay, that's fine. So let's now go and model the cantilever slab that we have here. Okay, that's fine. So back to our model file here. This is our staircase area. As you can see, the staircase area here, that's fine. Okay, that's okay. So with that now, let's now get model for the cantilever slab. Okay, so this is a freestanding column, that's fine, except it will connect around the roof area. Okay, that's fine. So again, right now, let's now go back to on our plan view. So on the plan view now, you can now see that we have cantilever lines around here. Okay, that's fine. We have cantilever around here and also cantilever around here. Okay, that's fine. These are lines of cantilever above. Okay, that's fine. So with this now, to first now model this cantilever line you are seeing here, we are going to use what? A ghost axis. Okay, so I'll come now and make sure I have my ghost axis, which I have here, and then try to draw goes axis like this. Make sure you pass it a bit to make sure you hold your control key and draw it this way. That's fine. And again, once that is being drawn, click on this other one again right now, and then hold your control key and draw it this way. That's fine. Okay, again, let me see that. Is that drawn? Yes, that's fine. Then again, hold your control key, click on this point, then come down, control key, and then click outside. So make just pass the point where they meet a bit. Okay, that's fine. And then escape. Again, click on this point, hold your control key, and then come again here. Click here. That's fine. Make sure it has inserted before you leave your control key. Now, once it is inserted, then come again, click on this point again, hold your control key to keep the line straight, then click here. That's fine. And again, leave that. That's fine. Again, come again, this point, hold the control key, click on this other point here. That's fine. Okay, that's fine. And again, let's go again from this point here now. Here, click on this point here, hold your control key and make this line straight and click here. That's fine. So with this now, let's now begin to now extend to make sure we have intersecting points at every point where the slab meet. For example, here now we need to stretch out this point a bit to make sure that the both lines intersect, else you don't have your slab here. That's fine. Again, come again here, click here, click here, right click here, else you'll be having issues to insert your slab. Okay, that's fine. And make sure you stretch it out a bit. That's fine. Again, here too, click on this place, right click here, and then stretch out a bit. That's fine. Click here. Okay, again, now click on this place, right click here, and then stretch. Now we repeat the same thing again on this other side, and then here too, repeating the same thing. Click here, and then come here, click, and then go here, and that's fine. So with this now, here too, make sure it passes the grid line. That's fine. And also here too, let's see, here needs to pass the grid line too to make sure it's intersected, to make sure they are both intersecting. Okay, that's fine. So with this now, we can now see what we've just done right now. Let's now begin to now put our slab right on this other side, on this other face. Okay, that's fine. So the same method using the pick point, you can see that I've also inserted this slab here. So make sure you use the pick point method very well. That's why you have to learn the pick point method, because you'll be using it to model any kind of slab shape that you want. Okay, that's fine. So we will then apply this cantilever load around this place, because if you look at on the 3D view, you can see that it has this slab edge here. As you can see, the edge here has a little bit of dwarf wall, which is for the balcony. So we need to apply this load too, and also this load here on the cantilever slab edge. That's fine. So back again now on this place here, so you can now see it here. So we also apply the load and then flow it load as this. You can see it right now. Okay, that's fine. So with this now, let's now go and also model the same principle. Now we also model for this other cantilever slab around here by doing what? Creating different grid lines. As you can see from this point, make sure they intercept. So let me take from this point now, control key. So I'll have to, so the same process right now, do the same thing and create yours on this other side too. That's fine. So after creating all these axes now, which you have seen me create now on the screen here, the next thing now to do is now insert the slab. So I'll come into modeling here, click on slab here, and then come here, make sure my slab is 150, because this is for the balcony area, and then come to my loading here. I'll come here 1.5, and then come again here, right click here, demonstrate views, and then come now, click on this place and make sure I am on the pick axis here. That's fine. So on this place now, I'll pick this point which I have here, and then come again now and make sure I see 0.1 there, and then make sure I see here 0.2. This will be 0.2. Okay, that's fine. Then come again here, this will be 0.3. So click on this other point here, 0.3. Here I'll show 0.3, and then move so on and then so forth. The same step, come here and pick 0.4, and then once you show 0.4 now, you then go and then pick 0.5. So the point option, the pick point option is the best method if you want to customize your slab panel. Okay, that's fine. So I'll come now and pick 0.5 now. Then you just see our slab now just appear just now perfectly. Okay, that's fine. So you can now see our slab now appearing. Escape key and then come here, modeling here. So if you can see the modeling here now, you can now see what we just have just got right now. We have the slab and we have the cantilever slab here. That's fine. Correct. So you can now see how our slab now is. Okay, that's fine. So you can now see also the trace plan that which you have now on the software 2025 Protastructure. So you can see the trace plan here right now, showing that this is the staircase area and this is the staircase for the okay, that's fine. So you can now see now, you can also see the cantilever here, which is the cantilever line showing here on the tracing plan, and then also see the cantilever up here, and the same thing happening here to cantilever line showing here on the ground floor, so on the tracing plan, and also and you can also see here too. So right now we have now done this. The next thing now we're doing is to now begin to now insert the cantilever load on each of the cantilever edge, and then insert the wall load, and then apply hinging on the beam, because we will have to release moment on the beam ends. Okay, that's fine. So you can now see how Ekidel is very, very good. Please, I would like to give this video a thumbs up, and also recommend your friends and colleagues about Ekidel. So okay, right now let's now move on to the next part, which is now to now model the to now apply the cantilever load and then the being load. Okay, that's fine. See you on the next video right now.